Our topic for today is all about set operations using Venn diagram. But before that, let us first identify the sets in our given Venn diagram. So first, we have our universal set. So always remember that the elements of the universal set are all elements inside our given Venn diagram. So in that case, you have here 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Those are the elements of our universal set. Next, let us now identify the elements of our set A. For the elements of our set A, all we need to do is to look for the elements that are inside the circle given for set A. Now in that case, you will have here 1, 2, 3, 4, and 5. After identifying the elements of the universal set and the elements of set A, let us now identify the elements of set B. In this case, we will be considering all elements that are inside the circle allotted for set B. So for set B, the elements will be 4, 5, 6, 7, and 8. Now, let us get A union B. Now, given this diagram, what we're going to do is to just look for the elements that are inside the circles of A and B. And that is going to be the union of A and B. So in this example, A union B will be 1, 2, 3, 4, 5, 6, 7, and 8. Now, let us get the intersection of A and B. Using this diagram, the intersection of A and B is this part. The part where the circle of A and B intersect or overlap. Now, for the elements of A intersection B, you will have here 4 and 5. A minus B. Using this Venn diagram, all we need to do is to look for set A, and then we're going to remove the elements of set B from A. Removing set B, the remaining elements will be 1, 2, and 3. B minus A. Using this Venn diagram, let us look at set B. All we need to do is to remove the elements of set A from B, and that will leave us with 6, 7, and 8. A complement, or the complement of A. Now, using this Venn diagram, in order for us to get the complement of A, what we're going to do is to look for the elements that are not within set A. So if this is set A, those elements outside this set will be its complement. And that will be 6, 7, 8, 9, and 10. Next, we have the complement of B. Just like what we did with the complement of A, all we need to do is to look at this diagram, look for the elements that are not within the circle of set B, and that will represent the complement of set B. So in this case, the complement of set B will be 1, 2, 3, 9, and 10. What if you are asked to get the complement of A union B? Looking at this Venn diagram, the union of A and B will be this part. Now, in order for us to get its complement, all we need to do is to remove this part, and the remaining elements will serve as its complement. And those are 9 and 10. Next, let's have the complement of A intersection B. Again, looking at this diagram, the complement of A and B is this part. Now, to get its complement, all we need to do is to remove this part, and the remaining elements will serve as its complement. And those are 1, 2, 3, 6, 7, 8, 9, and 10. Let us now move on to the complement of A minus B. Looking at this Venn diagram, the difference of A and B is this part. Now, in order for us to get its complement, all we need to do is to remove this part, and the remaining elements will serve as its complement. And those are 4, 5, 6, 7, 8, 9, and 10. Now, in this case, we have a Venn diagram with 3 circles for 3 sets, namely set A, set B, and set C. Let us now get the union of A, B, and C. Now, in order for us to get the union of A, B, and C, all we need to do is to combine all the elements that are within the circles of A, B, and C. And those are 1, 2, 3, 4, 5, 6, 7, 8, and 9. Next, what if we have A union B intersect C? Now, looking at this diagram, our A union B is this part. And then we're going to look for its part that intersect with C. And in that case, those are 4, 5, and 6. Next, what if we have the intersection of A, B, and C? Now first, we're going to look for the intersection of A and B. And the intersection of A and B is this part. And the part of the intersection of A and B that intersect with C is only this part. Therefore, the intersection of A, B, and C is 4. Let us now move on to A minus B intersect C. Now in this case, A minus B will be this part. And then the part of A minus B that intersect with set C is only this part. And that is going to be 5. Now let's move to the complement of the union of A, B, and C. So our first step here is to get the union of A, B, and C, and that is going to be this part. Now, in order for us to get its complement, all we need to do is to remove this part, and the remaining element will serve as its complement. And in this case, that is 10.